In 2.3, we'll be looking at measures of central tendency. So we'll be doing a lot of calculations. In this first video, I'm just going to show you how to find all of these. And then I will add a second video where I'm showing you how to do the same things using the TI-84 calculator. Remember, when you take a test, you will be required to show work, and I will go over exactly what I expect to see when you show your work, but there will be some things that you can get some numbers from the calculator and then write those down and then plug them into the formula, so you're not having to punch in every single number to get these sums that we're going to be doing. Okay, the first thing we're going to look at is the mean of a data set, and this goes back to probably 7th, 8th grade, when you first time you start hearing about mean, median, and mode. And the mean is an average. And we'll be using our symbols here because we'll have several formulas that involve the mean and other things. So the mean of a data set is the sum of data entries divided by the number of entries. And what you'll notice here is that we have two different formulas shown. One's called the population mean, and the other's called the sample mean. The population mean just means that we were looking at the entire population. So when we drew our data, again, if you were getting information from everybody at a university, that would be the population. But if you only pulled part of the people, that would be a sample. So they use different Greek letters to represent some of these. And so we have the Greek letter mu for the population mean. And then remember that this symbol is the Greek letter sigma, and it always means sum in math. So we're going to be finding a sum. So this says the sum of the data entries, and then the capital N represents the number in the population. When you get to the sample mean, we have what's called X bar. So it's X with a little bar over it. And then again, it's the sum of all the data entries, X. And then this time it's divided by a lowercase n. So a capital N represents the number in the population. A little n represents the number in the sample. And these will be important to remember as we go through and hit some other formulas, because sometimes you'll be finding a sample and sometimes you'll be finding a population. And on some of the formulas, they vary just a little bit based on whether or not it's population or sample. All right, so this first example, we're just finding a mean. And all that a mean is, and it says we're finding a sample mean. So we'll go ahead and call it, we'll use the X bar, use the correct symbols, X bar for the sample mean. And it says that to find the sample mean, we need the sum of the entries divided by the number in the sample. So the first thing we're going to do is we're going to find the sum of the X's. The X represents the numbers that were given. And this is the weight in pounds for a sample of adults before starting a weight loss study. And they want us to find the mean weight. So we're going to find the sum of the X's, or the sum of the entries. So you're just going to add these up. And you would just put all this in your calculator and add them up. And this total would come to 1,810. And then to find the sample mean, you take that number, the sum of the entries, divided by the number in the sample. And there's 1, 2, 3, 4, 5, 6, 7. So there's 7 in the sample. So it would just simply be 1810 divided by 7, which would be approximately 258.6. And that is rounded. And this is just a standard practice. Anytime you're doing these, unless they specify other ways, we're always going to round to one more decimal. One more decimal place than the original data. So what that means is, since our data was all whole numbers, then our answer would need to have one decimal place in it. If your data had one decimal place, then your answer would need to have two decimal places. It's always going to be one more than the original data. The next measure we're going to look at is median. And the median of a data set is the number or the entry that lies in the middle after you put the numbers in order. And we'll do this, and I'll show you an example where you have an odd number of entries and then what you do if you have an even number of entries. So the first thing here on example 2 that you're going to do is you're going to put these in order. So we have 223 first, and then 235. And if you want to mark these out as you go, you can keep up with them a little better. And then another 235. And then we have 268. And then 274, 285, and 290. And what you're doing is you're finding the number that's in the middle. So there's 1 on each end, there's 2 on each end, 3 on each end, and if you take those out, or if you keep up with that, that means that 268 is right in the middle. So the median here would be 268. On example 3, we're going to use the same entries, but it says that the adult weighing 285 pounds decided not to participate in the study. So what we're going to do is rewrite these, but we're going to take out the 285. And what that makes happen is it makes us have an even number of entries. So when you go from the ends, that leaves 2 numbers in the middle. And so what you do when there's 2 numbers left in the middle is you find the average of them. So you add and divide by 2. So we would add 235 and 268 and then divide by 2. So this would come out to 251.5, and that would be your median. Okay, the next measure is mode, and this is the easiest one. The mode of a data set is the entry that occurs with the greatest frequency. And very important, a data set can have just one mode, meaning there's only one number that occurs more than the other. It can have more than one mode, or it can have no mode. The no mode occurs when no entry is repeated. So if every entry was only written down once, then that data set would have no mode. If 2 entries occur with the same frequency, then we call that the same greatest frequency, then we call that a bimodal data set, because bi meaning 2, it has 2 modes. So if we look back up at the weights listed in example 1, and again, these were the same ones that we used again in example 2, so we can look right here, you'll notice that 235 occurred twice. So the mode would be 235 because it occurred with greater frequency than any others. If you're looking at a frequency table, the mode is even easier to find, because this is saying that Democrats, the frequency was 46. It was a political debate, and they were asked to name the political party to which they belonged. So 46 of the people said Democrat, 34 said Republican, 39 said independent, and 5 said other or don't know. So the one that occurred with the most frequency was Democrat. So Democrat would be the mode. An outlier is a data entry that is far removed from the other entries. So what that means is if all the numbers are kind of close together, and then you have one number that's much larger or one number that's much smaller, that would be considered an outlier. And then we're going to actually define outlier in section 2.5. They're going to give you a way to define it based on it's got to be a certain distance away from the others. The mean of a data set can be greatly affected by an outlier, because if you have a very large number mixed in with all the rest of them, that's going to raise the mean up. Or if you have a really small number mixed in, that may bring the mean further down. An outlier may be valid data, or it could be something that resulted as an error in recording. So it might not be an actual valid data. It may be something that shouldn't have been there because whoever was recording it put the wrong number down. So that's always important to keep in mind. All right, in example 6, we're going to compare the mean, median, and mode, and we're just going to see what it looks like when you're looking at these numbers, how the 3 measures compare, and which one you think really represents the data set the best. All right, so the first one is to find the mean. And remember, to find the mean, this is a sample, so we use the X bar to represent sample mean. And we're going to find the sum of the x's and divide by the number in the sample. And I'm not going to write all of these out again. You can just put these in your calculator, 20 plus 20 plus 20 plus 20 and so forth, and add all of these up. and the sum comes to 475. And if you count the number of people in the survey, there were 20 people in the survey. And what this is showing is the ages of students in the class. So when you divide this, and remember we'll go to one decimal place, we get about 23.8 years old. So that would be the average or the mean age of the students in the class was 23.8 years old. The next one is the median. And this one's nice because they're already in order for us. So if we count 20, then if you take off 9 from each end, that leaves 2 numbers in the middle. And if you get confused when you're doing this, what you can do is you can actually just very lightly mark off one at a time. So you go 1 from each end and just go 1 at a time from each end, like so. And then when you're left with only 1 or with 2, then you're ready to find your median. So the 21 and the 22 are in the middle. So remember, if there's 2 in the middle, we add and divide by 2. So when you add those, you would get 21.5 years old. And then finally the mode, and that's the easy one to find, which one occurred the most. And it's very easy to tell that 20 occurred more than any others. So 20 years old. So we found the mean, median, and mode. It says, are there any outliers? And obviously you can tell just by looking. 65 is much greater than the others. So we would say 65 is an outlier. And again, that may be an actual, there may be a student in the class that's 65, or somebody may have recorded it wrong. They may have accidentally put a 6 when it was supposed to be a 25. So you don't know, but that is considered an outlier. And what we want to do is we're going to look at which measure of central tendency best describes a typical entry of the data. Well, the 65 being an outlier, remember that's going to affect, it's not going to affect the median and the mode, but it does affect the mean because it wasn't included. The median came from the 21 and 22, and the mode came from all the 20s. So 65 didn't affect those, but it did affect the mean. So by that being an outlier, the mean is affected, which means that it caused the mean to be higher than it would have if the 65 hadn't been there. The median considers all the data entries. It has all of them in order, and it includes the 65, but it's not affected by the 65. So the median includes all entries, but not affected by the outlier. And then the mode, remember the mode only ever considers one number. So the mode only considers that one entry that occurs more than the others. So it only considers the 20. So if you were going to best describe this data set, the median would be the one that you would want to use because it included all the entries and was not affected by the outlier. The next thing we're going to look at is called the weighted mean and mean of grouped data. So a weighted mean occurs when different data entries have a different weight. The easiest way to think about this is in a class, if your tests have a greater weight than your homework. So let's say maybe your tests count 70% and your homework only counts 30%. That would be a weighted average, and that's what a weighted mean is. So a weighted mean is the mean of data set whose entries have varying weights. So some of the entries carry more weight than the others. And the way you're going to do this is you're going to do the sum of the products of the entries and the weights. So you're going to multiply each entry by its weight, and then you're going to divide by the sum of the weights. And W stands for the weight. So to make that a little clearer, we'll look at an example. And when we look at this example, it's one having to do with grades. It says your grades from last semester are in the table. And the grading system assigns points as follows. So this is like getting your GPA. So an A has more weight than a B, and then a C, a D, and an F. And this is how you determine your grade point average. So what we want to do is we want to find the grade point average based on what you have here in the table. So you had 3 credit hours and you earned a C. You had another class that was 4 credit hours, you earned a C there. A 1 credit hour class got a D, 3 credit hours an A, 2 credit hours a C, and 3 credit hours a B. So when you do this, you're going to, first of all, look in the table and give this the number of, or the weight that's assigned. The grading system assigns points. So a C gets 2 points. So that C gets 2 points. A D gets 1 point. An A gets 4 points. Another C gets 2 points. And a B gets 3 points. And then the number of credit hours determines how many total points you get for that class. So since this was, you got 2 points for making a C and there was 3 credit hours, that would be a total of, when you multiply the X times the weight. So X is your 2, your weight is 3, 2 times 3 would be 6. And then here 2, but that was 4 hours, so it carries more weight than a 3 credit hours, so that was 8. And then 1 times 1 would be 1. 4 times 3 would be 12. Here you've got, your weight is 3, and you got 4 points for each of those, so 12. 2 times 2 is 4. 3 times 3 is 9. So that would be your X times W. So we're thinking of this as the X, which is the number of points for the grade, and then W is the number of hours you have, and that would be your weight. And then what we need to do is, based on this formula up here, the sample mean would be the sum of the X times W's divided by the sum of the W's. So if we add these up, 6 plus 8 plus 1 plus 12 plus 4 plus 9, this would be our sum of X times W, and that is equal to 40. And then here, this is our W, so if we added these up, 3, 4, 1, 3, 2, and 3, that would be the sum of the W's, or the sum of the weights would be 16. So we get 40 over 16, and when we divide that, you would get 2.5. So your GPA would be a 2.5. And that's how you do a weighted mean. The mean of a frequency distribution for a sample is going to be the sum of X times F. And what happens here, this occurs because you have a given X occurs multiple number of times. So rather than do it over and over again, we just do X times the number of times it occurs, and then again divided by the N, which is the number in the sample. And note that N is the sum of the frequencies, because N is the total number of entries. And this gives you a guideline for finding the mean of a frequency distribution. So if we're using a frequency distribution, you want to find the midpoint of each class. And we did that in an earlier lesson, where you do the lower limit plus upper limit divided by 2. And then you're going to find the sum of the products of the midpoints. So the X's are going to be your midpoints. And then that's going to be multiplied by the frequency. Add those up. And then the sum of the frequencies will be the total number of entries. And then to find the mean, we divide. So we'll walk through an example with that. So on this one, and this goes back to the example we did in an earlier section, where we had the class limits, or the classes 155 to 190, 191 to 226. And this is talking about the out-of-pocket prescription medicine expenses. So when we look at these, we want to find the midpoints of the classes. So I'm going to do that out here to the side. You can look back to your earlier notes, but if you've forgotten, the way we did this was 155 plus 190 divided by 2 to find that midpoint, and that comes out to 172.5. So these are the midpoints. 172.5, 208.5, 249.5, 280.5, 316.5, 352.5, and 388.5. So this is just by adding and dividing by 2 to get each one of these numbers. Okay, once you do that, the midpoint, that's going to be your X. And then your frequency obviously is your F. So these are your X's, and then your F's are over here. And that's what we're going to be looking at to use this formula from up here. We need the sum of the X times F. Okay, now I was checking this. This is 244. I couldn't tell if that was a 4 or a 9. That's 244.5. All right, so once you've done that, then we're going to do X times F. And you can do this all at once in your calculator, but a lot of times it's better to do them individually, and that way you don't risk making a mistake. So we're going to multiply 172.5 times 3, and that's going to get our X times F. And then you're going to multiply 208.5 times 2, and that's going to get you 417. And then you just continue doing that, multiply the midpoint by the frequency, and you'll finish out this list. And you'll notice in the list it says that we want the sum of XF. So we're going to come down here and we're going to find the sum of these numbers that we just found. And that sum would be 8,631. And we already have the sum of the frequencies. That's right here. And that's what N is. So this is my N here. N would be 30. And then what you're going to do is you're going to say that the sample mean, remember that's X bar, is equal to the sum of XF divided by the number in the sample, divided by N. So this would be 8,631 divided by 30, and that would be 287.7. And that would be the mean of a frequency distribution. And again, we can do this on the TI-84 graphing calculator, and I will show that in a separate video. All right, the last thing we're going to look at is just look at some graphs, and we're not going to calculate anything, so this part will be quick. This is the shape of your distribution, and if you draw a frequency distribution graph, it is called symmetric when a vertical line can be drawn through the middle of the graph and the resulting halves are approximate mirror images. So I'll come down and show you the example that looks like this. So right here we have a symmetric distribution. If you go right down the middle of this graph, you can see that, actually I need to move over just a little bit. So if you go right in the center of the graph right here, you can see that the two halves, this side and this half, are mirror images of that. So this is called symmetric because it's the same on either side. And what you'll notice here is that when it's symmetric, the mean, median, and mode will all be the same number. They all line up. Mean, median, mode are all equal. So it's symmetric, and it's also unimodal, meaning it just has one mode. A frequency distribution is uniform or rectangular when it forms a rectangle. So that means all the entries or all the classes are the same or approximately the same. They might be just a little bit different. And you can see that one in this one here. Uniform distribution, it forms a rectangle because everything's approximately the same. So when the midpoint is 1, we've got about 20 of those. When the midpoint's 3, we got about 20 of those, and so forth. And you'll notice that this is also symmetric because you could still find a middle here and the halves were the same. So what happens here is the mean and the median are the same. The mean and the median are the same. But they would all pretty much occur the same number of times, so that's why you don't see a mode listed here. Okay, and then the final two will either be skewed left or skewed right. And it's skewed when you have a tail. So one side of the graph is longer. You can see that here. One side of the graph is longer than the other side, and that's called skewed. A distribution is skewed left or negatively skewed when its tail extends to the left, and it's skewed right when the tail extends to the right. So when we look at these, you can see by looking at these that, I'll get rid of these marks I made. You can see here that when it's skewed to the left, the higher points are all to the right, and then it kind of slides down to the left. So this over here is your tail, this part here where it goes to the left. When this happens, the mean will always be less than the median. The mean will be less than the median. It's skewed left. That means that you've got smaller numbers that are affecting the mean. So it's pulling the mean down. The median is usually less than the mode. Okay, not always, but the mean will always be less than the median. When it's skewed to the right, that means you have some larger numbers that it's affecting the average. So when it's skewed to the right, the mean will be greater than the median. And then the median will usually be greater than the mode. And again, this is usually, not always, but usually. But this part right here is always true. Skewed left mean less than median. Skewed right mean greater than median. So the importance of this is you can look at a data set and you can identify something. You can compare the mean, median, and mode without actually having to know all of the points and actually figure those out.